Hello and welcome back to our webcast series on the topic of interpenetration. In this video we're going to look at a pretty common problem that we're faced when we're dealing with the topic of interpenetration, and that's when you have two solids and one of the solids is an inclined or angled solid. So we're going to look at the theory behind how we actually set up the question. So we're going to begin by taking a look at our example. Here we have an upright cylinder and we have our inclined cylinder that's going to be in contact. Here in 3D, here we have an elevation and plan view. And this is actually a common enough problem because for the likes of, say, ducting and that, this is what's known as a saddle joint. And you can actually buy things like this where you can see it's a half cylinder which you can actually pop onto an existing duct or pipe and weld it into place. So we're going to see how do we set it up to find this curve of interpenetration. To begin, we're going to start by drawing in the profile, or the true profile of our inclined cylinder. We can see we don't have this circular profile in either our elevation or in our plan view. In plan view it's distorted as an ellipse. So we need to go and look along our center line here and take an auxiliary to do that. So if we're looking along our center line, our auxiliary is going to be perpendicular to that, our x1, y1 line, and we're going to project our center line along, and we're going to draw in our circle. Now, for a normal auxiliary, the position of our center point here would be the distance that we would have off the xy line would be the same as the distance it would be in our plan view. So that's where we're drawing in our auxiliary, like so. I'm going to do it in 2D, and I'm going to also do it in 3D here as well. So here is our auxiliary giving us the true profile of our object, and you can see I've divided it up into 4 different points. Here we have T, U, B and F. T stands for the top edge, U for the underside, F for the front and B for the back. So if we do it in 3D, we'll do it over here in 2D as well. So we break it up into 4 equal quadrants using this center line here as our baseline and going perpendicular to it. So just be careful, not straight up and straight across. We're using this as our baseline, as our horizontal line. You can see here we have our top, our underside, our front and our back. Now the top is pretty straightforward. There's the top edge like so, there's the underside like so, but when it comes to the back and the front, that's where some students have a little bit of difficulty visualizing it. And you just must remember that our XY line here represents this hinge line here, where our auxiliary plane crosses the vertical plane, or the back wall. And you can see the point B is the closest to that hinge line here, so that's why B is the closest here, like that. Another way to visualize it would be, just let's look in it like so. You can see there's our back wall, B is the closest to the back wall, hence being at the back of the object, and F is the furthest away from it. That's why it's like that. And if we can just imagine our object, so there's our auxiliary like that. Really what we're doing is we're hinging him out like so. So you can see F ends up in the position that we have it there, like so. So B then is at the back of our object, like so. So that's how we're able to do it. And I find that labeling it T, U, F and B really helps to visualize the way the object is orientated. So that's our profile in elevation. Next, what we're going to do is draw in our profile in our plan view here. So really we're going to just hinge him back as well, like that. And that's the equivalent of hinging our object like so. So when we look from above, we're seeing the true shape in our plan view. So we're going to break it up into quadrants like the last time, and this time we're going to label it like that. And you can see the labeling is slightly different to what we have up here. This time the back is going to end up here, the front is going to end up here, so that's quite straightforward. And this time the top ends up further away and the underside ends up closer. And you can imagine there's because the underside there ends up like so. So you can see there's the top ends up further away. So that's the reason why that's orientated. And that really does come into one of the most common mistakes that students make. They mislabel the top and the bottom, and then when it comes to drawing in their object, they don't line up. So that's the top and the underside like so. Then we're going to just divide up our object again using this edge here as the base for our protractor or for our set squares. And like the a clock, I'm going to say 12 is at the top, and we're going to work our way around like that. We're going to do the same with the plan view of it. Again, here is the top of our clock, so this is where our 12 is going to be, not up here like so. Remember, T and 12 must correspond with your elevation here like so. And once we have that, then it's just a case of locating our curve of interpenetration. So we project each of our points, so in this case 3 and 9, we locate them on our second solid, project them up, And then we just project 3 and 9 down here to locate our point. And we do that with each point. So 2 and 4 goes back, 10 and 8 goes back. We bring it up, and we just project them down like that. And we're just literally corresponding or joining up the points that from elevation and plan. So we do the same with the rest of our points, and that gives us each of our points like that, giving us our curve of interpenetration on our saddle like that. So that's the curve of interpenetration for an inclined cylinder and a vertical cylinder. Now what we're going to do is we're going to use the idea of orientating our object here like that, or auxiliary here like that, and we're going to put that into action into a full leaving certificate question in the next video. So if you want more information, you can just stay tuned to our next video. And if you want any more information about GMIT Letterfrac or any of the courses on offer, you can go onto the GMIT website shown here. So hopefully this has been of some help to you. Thank you very much.